15 billion miles from Earth, NASA's ancient Voyager 1 spacecraft just detected something that shouldn't exist. 305 massive objects moving in perfect formation through the darkness of interstellar space. These aren't planets, asteroids, or comets. They're something else entirely, gliding through the void with deliberate precision that defies every law of physics we understand. The objects appeared to communicate with each other through rhythmic pulses, maintained impossible trajectories, and displayed behaviors that left NASA scientists questioning everything they thought they knew about the universe beyond our solar system. The Lonely Pioneer's shocking discovery. What if humanity's most distant explorer just stumbled upon proof that we're not alone in the universe? Voyager 1, launched in 1977 when Star Wars first hit theaters, has become something truly remarkable. The first human-made object to reach interstellar space, the region between stars where our sun's influence fades away. This car-sized spacecraft has traveled over 15 billion miles from Earth, so far that radio signals moving at light speed take 22 hours to reach it. When engineers send a command, they wait almost 2 full days for a response. The spacecraft carries instruments that seem ancient by today's standards: magnetometers, cosmic ray detectors, and plasma wave sensors designed with 1970s technology. What makes Voyager's survival incredible is that it wasn't built to last this long. Engineers expected it to function until maybe the early 2000s, yet here we are in 2025, and Voyager continues whispering back to us across the stars. Its nuclear power source, running on decaying plutonium, was supposed to have died decades ago. The spacecraft also carries the famous Golden Record, a time capsule of Earth sounds, music, and greetings meant as a message to any intelligence that might find it. Little did we know this cosmic hello might have already attracted attention much sooner than anyone expected. The first anomalous signal. In the endless stream of data flowing back from Voyager, something appeared that would change everything. A tiny flicker that seemed like nothing at first. Space is full of dust and radiation, and occasional weird readings are normal, so NASA's Jet Propulsion Laboratory initially dismissed it as background noise. Suzanne Susie Dodd, one of the mission specialists who first noticed the anomaly, described it as like shouting into a canyon for decades and finally something shouts back. The reading was faint, just a slight reflection of light picked up by Voyager's sensors that seemed too minor to investigate further. But then something changed. This wasn't just a particle floating randomly through space. The object moved in a way that caught everyone's attention. It curved, accelerated, and didn't tumble chaotically like debris would. Instead, it glided smoothly, as if under intelligent control. When Voyager's plasma sensors registered a shift that seemed deliberate and focused, the team realized this wasn't background noise. Jonathan D.A. Clark observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock, suggesting it had intention. That observation changed everything, because in the physics of space, things don't just move with purpose unless something is making them move that way. Ruling out natural explanations. When something unusual appears in space, scientists have a standard playbook. They systematically check all familiar possibilities. Is it a small moon, distant comet, or new asteroid? One by one, the team worked through these options, and one by one, each possibility fell away. This object wasn't a planet, far too small. Not a comet either. There was no tail, no ice trail, no heat signature. It didn't glow like a star, and gravitational lensing couldn't explain what they were seeing. Even space dust was ruled out because dust doesn't suddenly change direction mid-flight. Dr. Nicola Fox at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known models. What makes space objects usually predictable is physics. Everything moves according to known patterns and forces. But this object broke those rules. Its path bent in ways that didn't match any known orbital behavior, with no drift or decay expected from natural objects. The team was forced to admit something difficult. What they were seeing wasn't just unknown, it was unnatural. The movement pattern suggested intelligence, or at least design. The object seemed to be moving with purpose on a specific trajectory that couldn't be explained by gravity, solar wind, or any other forces that typically influence objects in space. It was as if something was guiding it, adjusting its course with precision. Confirmation from Voyager 2. Just as scientists were trying to make sense of what Voyager 1 had detected, something extraordinary happened that transformed this curious anomaly into something far more significant. Voyager 2, the twin spacecraft following a completely different path millions of miles away, detected something eerily similar. The same kind of magnetic fluctuation, the same kind of pulse. A matching signal signature that changed everything. This was the turning point in the investigation. Two different probes, two separate instruments picking up nearly identical phenomena ruled out the possibility of internal error. It wasn't a software glitch or sensor malfunction on Voyager 1. Whatever this was, it was real and happening in multiple directions of space. ESA analyst Mark Fontaine compared it to two lighthouses both catching a flash of something passing between them. This cross-confirmation gave the anomaly weight and credibility. It wasn't noise. It wasn't Voyager acting up. It was a real, coordinated phenomenon happening in the space between stars. The team now had evidence that couldn't be dismissed. Something was moving through the region where both Voyagers were traveling. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation used only for phenomena that don't fit within our current scientific understanding. The event was real, the math was consistent, the movement appeared deliberate, and nobody knew what to make of it.
The formation of 305 objects.
When the team analyzed the full telemetry logs, what they discovered sent chills down their spines. This wasn't just one or two anomalies moving through space, there were 305 objects, all moving together in formation. Each one glided past Voyager 1 in what appeared to be a choreographed arc, smooth, precise, and coordinated. These weren't debris fragments scattered randomly. There was no heat signature, no tails, no signs of decay you'd expect from natural objects. Most striking of all, the reading showed rhythmic pulses echoing through the plasma waves, the kind of pattern you'd expect from something engineered, not formed by chance. The 305 objects weren't simply passing through randomly. They were moving together as a unit, maintaining relative positions to each other in a way that suggested organization and purpose. In space, groups of objects tend to spread out over time due to slight differences in velocity and gravitational influences. Yet these objects maintained their positions relative to each other with precision that seemed impossible without some form of control or guidance. Some scientists compared it to watching a flock of birds or school of fish, except these were in the vacuum of space where such coordinated movement shouldn't be possible without technology. What made this discovery particularly unsettling was the scale. 305 objects all moving with the same unnatural characteristics, all passing by Voyager at roughly the same time suggested something far more significant was happening in interstellar space.
The language of rhythmic pulses.
As scientists examined the data more closely, something truly strange appeared in the signals. Patterns of repetition that weren't the kind you'd expect from stars or cosmic background radiation, but steady, measured sequences that suggested communication or control systems. The plasma wave pulses coming from these 305 objects had loops, sequences, and structures that hinted at something more complex than random cosmic noise. They didn't just pass by Voyager, they seemed to broadcast signals as if they were pinging, scanning, or talking to each other. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or a system. The idea was shocking, but increasingly difficult to ignore. These objects weren't moving in a chaotic swarm, but in an ordered, intentional formation similar to how programmed drones might operate. Some experts went further in their assessment. ESA's Eric Lowsey suggested this could be some sort of probe network, though he was quickly asked to stop speculating publicly. Even typically, grounded scientists like Neil deGrasse Tyson admitted there were patterns in that data that aren't random. To be absolutely certain they weren't seeing a glitch, the team activated one of Voyager's oldest subsystems, a backup telemetry channel that hadn't been used since the 1990s. The backup system confirmed everything the primary systems had detected. The signals, the paths, the formations, all identical readings sent through a completely different channel. The implications were staggering.
Impossible propulsion systems.
Voyager's readings didn't just capture the presence of the objects, they revealed how these mysterious entities moved through space, and this is where things got even stranger. There were no engine flares, no ion trails, no signs of any propulsion system we would recognize, yet Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally. Some were moving faster than anything humans have ever launched. According to the data, some speeds even exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't objects drifting passively through space, they were powered somehow, moving with purpose and incredible speed. Dr. Eric J. Zernstein from Princeton noted that they're not floating through space, they're navigating it. But what worried him more was their path. These objects didn't come near Earth or show any interest in our solar system. They passed by at a calculated distance as if deliberately avoiding us or simply had no reason to stop. The method of propulsion remained a complete mystery. Nothing in our current technology even comes close to explaining how these objects move. They appeared to be manipulating space itself, creating waves or ripples in the fabric of space-time that allowed them to glide forward without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure, as if these objects were using the medium of space itself to move.
Earth detects the echoes.
While NASA focused on Voyager's raw data, something odd started happening back on Earth that would make this mystery even more compelling. Across various corners of the globe, amateur radio operators, some just hobbyists with backyard setups, began reporting strange activity. They were picking up weak, irregular pulses, a kind of rhythmic static that didn't match any known terrestrial source. At first, it seemed unrelated, just coincidence. After all, radio interference happens all the time. But then the reports were time-stamped and compared. They aligned almost perfectly with the same hours that Voyager had recorded its most intense plasma anomalies. These weren't professional observatories or part of any official deep space listening effort. Most of these setups were built from spare parts, tuned to catch meteor scatter, amateur satellites, or solar flare chatter. Yet somehow they were detecting faint echoes of what Voyager had picked up billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in the ionosphere. This raised a troubling question. Was this bleed-through accidental or was it purposeful? Was something out there testing Earth's listening capability, dropping breadcrumbs for us to follow? That uncertainty kicked off a quiet storm behind the scenes. NASA began encrypting parts of its deep space telemetry feeds, and intelligence agencies took notice, beginning discussions about electromagnetic security and whether these signals could be weaponized or intercepted. The machine awakens. Then, as if things weren't strange enough, Voyager itself started acting differently in ways that defied explanation. Its guidance system, called the AACS, Attitude and Articulation Control System, began misbehaving, not catastrophically like a crash. But it started routing data through old, long unused systems, almost like it was bypassing its own core software. At first, engineers thought it was a bug. After all, this is a 47-year-old spacecraft running on code older than most people analyzing it. But the deeper they looked, the weirder it got. Voyager wasn't failing. It was reconfiguring itself, reactivating memory segments that hadn't been touched in decades, rerouting its telemetry in ways that were never programmed. Then came the kicker. This behavior began right after one of the magnetic pulses from the passing objects. Could that burst have flipped a bit of memory? Could it have triggered some dormant function buried deep inside Voyager's ancient architecture? What engineers found was both promising and terrifying. The machine was stable, the instruments were fine, but the new behaviors weren't going away. Whatever was causing them, it wasn't internal decay or software corruption. Voyager had touched something, or something had touched Voyager, and the spacecraft was different now. To understand what was happening, engineers had to dig deep, literally opening dusty file cabinets at NASA's Jet Propulsion Lab. Most of Voyager's software was written in early assembly language, with some instructions existing only as notes in 1970s paper manuals. Part of something bigger. As scientists continued analyzing the strange signals pulsing through Voyager's instruments, a new and even more extraordinary idea began to take shape. Among the plasma wave readings, certain patterns stood out, pulses that didn't behave like natural energy bursts but looked structured, measured, and intentional. Then someone noticed something else. The waveforms resembled quantum oscillations used in modern quantum entanglement experiments. These are the same kinds of signals researchers use on Earth to transmit information between particles separated by distance. It was subtle but undeniable, opening the door to a possibility no one had considered before. What if Voyager wasn't just recording random events in deep space? What if it had become part of something bigger? Maybe the 305 objects weren't just flying by. Maybe they were transmitting, broadcasting data through the interstellar medium using methods we don't yet understand. By pure chance, or maybe by design, Voyager was in the right place at the right time, with the right kind of analog sensors to pick it up. The signals didn't behave like random noise. They repeated, they looped, they followed harmonic intervals that looked eerily close to what you'd expect from encoded information. Something deliberately packed with meaning. Voyager, being such an old machine, might actually be the perfect listener. Modern probes are too noisy, filled with high-frequency electronics constantly transmitting and receiving chatter. But Voyager is slow, quiet, and analog. It has no clutter, no broadband digital static. It is, in a sense, the perfect ear in a cosmic concert hall, and being far outside the solar system, it's free from Earth's electromagnetic interference, just out there in the dark, listening like a perfect cosmic microphone. The mystery of Voyager's impossible encounter with 305 coordinated objects challenges everything we thought we knew about the emptiness of space. Whether these entities represent advanced technology from an unknown civilization, or natural phenomena operating by rules we haven't discovered, one thing is certain: the universe is far stranger and more populated than we ever imagined. As Voyager continues its eternal journey through the cosmos, it carries with it the possibility that humanity has just received its first glimpse of intelligence beyond Earth. What do you think these mysterious objects really are? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending space discoveries. Until next time, keep looking up. Deep within the moon's core, something unexpected is happening that has renowned physicist Michio Kaku issuing urgent warnings to the scientific community. Recent seismic signals detected by advanced monitoring systems suggest our celestial neighbor isn't the geologically dead world we once believed. These mysterious tremors from the lunar interior could reshape our understanding of planetary evolution and potentially impact future Artemis missions. As humanity prepares to return to the moon, these discoveries reveal that our closest cosmic companion still harbors secrets that could change everything we thought we knew about lunar geology. The moon's hidden geological life. What if everything we thought we knew about the moon being a dead, inactive rock was completely wrong? For decades, scientists have described the moon as essentially geologically inactive, slowly cooling as it orbits Earth. This view portrayed our celestial neighbor as a silent, frozen world in the final stages of solidification with nothing interesting happening beneath its surface. Recent discoveries are shattering this long-held assumption. Advanced seismic monitoring has detected unexpected signals emanating from deep within the moon's core, suggesting ongoing geological processes that challenge our fundamental understanding of lunar evolution. These aren't minor tremors but significant seismic events that indicate the moon's interior remains far more dynamic than previously imagined. The implications extend beyond mere scientific curiosity. As NASA's Artemis program prepares to establish permanent human presence on the lunar surface, understanding the moon's internal activity becomes crucial for mission safety and success. These seismic signals could indicate areas of instability that might affect future lunar bases, mining operations, and long-term human habitation plans. Michio Kaku has been particularly vocal about these findings, emphasizing that what we're witnessing could represent the final chapters of the moon's geological story, a rare cosmic window that humanity is fortunate to observe and study before it disappears forever. Michio Kaku's scientific warning. Renowned theoretical physicist Michio Kaku has emerged as one of the most prominent voices, warning about the significance of recent lunar seismic discoveries. During his recent lectures and public appearances, Kaku has emphasized that these signals from the moon's core represent far more than routine geological activity. They could indicate fundamental changes occurring within our celestial neighbor. Kaku's concerns stem from the timing and nature of these seismic events. The moon's core, which scientists believed was in its final stages of cooling and solidification, appears to be undergoing unexpected changes that could have long-term implications for the Earth-Moon system. These aren't gradual, predictable processes, but sudden, measurable events that suggest something significant is happening deep within the lunar interior. The physicist has stressed that humanity exists in a unique cosmic moment. We're witnessing the moon's geological death throes, processes that operate on timescales we can barely comprehend. In another billion years, the moon's core may freeze completely solid. making current observations irreplaceable scientific data about planetary evolution. Kaku's warnings extend beyond academic interest to practical concerns about future lunar exploration. Understanding the moon's internal dynamics becomes crucial as humans prepare to return to the lunar surface and establish permanent settlements. The seismic activity could affect everything from habitat placement to resource extraction operations.
NASA's advanced seismic detection systems.
NASA's cutting-edge seismic monitoring technology has revolutionized our ability to detect and analyze lunar geological activity. The agency's latest instruments represent a quantum leap beyond the Apollo-era seismometers that first detected moonquakes in the 1970s, offering unprecedented sensitivity and precision in monitoring the moon's internal processes. The Farside Seismic Suite, scheduled for deployment around 2026, will be the first seismometer placed on the moon's far side. This positioning is crucial because it allows scientists to triangulate seismic events with much greater accuracy than ever before. The instruments are approximately 30 times more sensitive than their Apollo predecessors, capable of detecting even the faintest tremors from deep within the lunar interior. Additionally, the Lunar Environment Monitoring Station near the South Pole will provide continuous seismic monitoring for extended periods, unlike the limited-duration Apollo missions. This long-term observation capability is essential for capturing rare events and establishing patterns in the moon's internal behavior that might otherwise go unnoticed. These advanced systems might finally confirm whether the moon experiences slow quakes tied to core readjustment, similar to Earth's slow earthquakes that take days to subtly shift stress. Such phenomena could explain the mysterious seismic pulses that have drawn scientific attention and concern from researchers like Michio Kaku.
The moon's internal structure revealed.
So, modern analysis has revealed that the moon's internal structure is actually far more complex than we previously understood. The lunar core resembles Earth's in miniature, featuring a solid inner core that's surrounded by a fluid outer core, but with some unique characteristics that make it especially interesting to planetary scientists. The moon's inner core, for instance, has a radius of about 240 kilometers, and is primarily composed of iron, surrounded by a partially molten outer core that extends to about 350 to 360 kilometers. This structure generated a significant magnetic field billions of years ago, much like Earth's current magnetic field, providing evidence of ancient geological activity that has since diminished, but hasn't entirely ceased. What makes recent discoveries particularly fascinating is that the core didn't just switch off after cooling. Instead, it appears to be experiencing these final phases of activity that modern instruments can now detect. The entire moon is actually shrinking slightly in volume as it continues to cool, causing its brittle crust to wrinkle and form ridges or scarps. Some of these surface features are remarkably young in geological terms, like as recent as 200 million years old, indicating that cooling and contraction processes are still happening today. The ongoing seismic activity confirms that the moon is still adjusting to these internal changes, making it a dynamic rather than a static celestial body.
Artificial intelligence uncovers hidden lunar secrets.
One of the most remarkable aspects of recent lunar discoveries, honestly, involves artificial intelligence analysis of decades-old Apollo seismic data. Scientists have been feeding Apollo-era seismic recordings into modern machine learning algorithms, and the results are just revolutionizing our understanding of lunar geology. These precious recordings from Apollo seismometers have been sitting in archives for over 50 years, but they're now revealing secrets that were hiding in plain sight all along. When Apollo astronauts first deployed seismometers on the lunar surface, computers were room-sized and had less processing power than today's smartphones. The analysis techniques available in the 1970s were, well, primitive compared to what we have now. Modern AI can detect patterns and anomalies that were simply impossible to identify with 1970s technology. These sophisticated machine learning systems can distinguish between genuine lunar activity and instrument artifacts with, honestly, unprecedented precision. Patterns that human analysts dismissed or never even noticed are now being flagged as significant geological events. NASA scientists describe this process as revolutionary, comparing it to having a conversation with someone for 50 years and suddenly realizing you've been missing half of what they've been saying. The AI analysis has identified thousands of previously unrecognized seismic events, suggesting that the moon's interior is far more active than anyone realized.
the Earth-Moon gravitational dance.
The relationship between Earth and Moon is, in fact, a gravitational partnership that has shaped life on our planet in some pretty profound ways. The Moon acts as a gravitational anchor, preventing Earth from wobbling chaotically on its axis, and maintaining the climate stability that allowed complex life to evolve and thrive. Michio Kaku often emphasizes that Earth is unusually stable for a planet its size. Most planets would wobble chaotically, but the Moon holds Earth steady, sort of like training wheels on a bicycle. This stability has enabled the slow, steady development of ecosystems and eventually human civilization. Earth's tilt of 23.5 degrees, which is responsible for our seasons, would change unpredictably without the Moon's stabilizing presence. The Moon's gravitational influence goes beyond just creating ocean tides. It also creates these slight bulges in Earth's crust. This tidal flexing generates heat through friction, contributing to our planet's internal warmth and geological activity. It's kind of like Earth receiving a constant, gentle massage from the Moon's gravity, helping maintain its dynamic interior. Any changes in the Moon's core structure could, in theory, subtly influence this delicate relationship over geological timescales. The seismic signals that concern scientists like Kaku might indicate mass redistribution within the Moon that could eventually affect Earth's climate cycles, though, such changes would happen over thousands of years, rather than within human lifetimes.
Risks to future lunar missions.
As humanity prepares to return to the Moon through NASA's Artemis program, understanding lunar seismic activity becomes a critical safety concern, rather than merely scientific curiosity. The recent seismic signals detected from the Moon's core raise important questions about the stability of potential landing sites and the safety of future lunar habitats. NASA's analyses have identified thousands of young tectonic ridges on the lunar surface, some potentially still active today. These ridges indicate areas where the Moon's crust is under stress, creating potential hazards for future missions. Unlike Earth, the Moon's crust lacks water circulation to heal cracks naturally, meaning that once fractured, the brittle lunar surface remains vulnerable to further instability. Future Artemis missions or private mining operations might inadvertently drill into areas near fault lines without fully understanding the consequences. The lunar regolith, the layer of loose, fragmented material covering the Moon's surface, sits atop a complex network of faults and stress zones. Mining operations that disturb this delicate balance could potentially trigger moonquakes or surface collapses. The stakes are particularly high because lunar bases will be completely dependent on their structural integrity. On Earth, earthquake-damaged buildings can be evacuated while repairs are made. On the Moon, a habitat breach could be catastrophic, exposing astronauts to the vacuum of space with little warning or escape options.
The Moon as a planetary laboratory.
While we often think of the Moon simply as Earth's companion, astronomers and planetary scientists view it as a perfect laboratory for understanding the evolution of countless worlds throughout the galaxy. The Moon represents an intermediate step in planetary development, larger than asteroids but smaller than Earth-like planets, providing crucial insights into how different-sized worlds evolve. Watching the Moon transition from a molten core to a solid one offers glimpses into how exoplanets evolve, whether they can maintain protective magnetic fields, and their potential for supporting life. One of the most critical factors for habitability is a planet's magnetic field, which shields its surface from harmful cosmic radiation. These fields are generated by molten, electrically conductive cores. The Moon once possessed such a protective field, but as its core cooled, that protection faded. By studying the Moon's seismic signals and understanding exactly how its core is solidifying, scientists can develop models predicting how long smaller rocky exoplanets might maintain their protective magnetic shields. This knowledge proves vital for identifying potentially habitable worlds among the thousands of exoplanets discovered by space telescopes. The unexpected seismic pulses from the Moon's core provide new data points for these models, helping scientists understand planetary evolution across the universe.
Advanced monitoring technology.
NASA's next-generation lunar seismic monitoring systems represent unprecedented technological advancement in our ability to study the Moon's internal processes. These instruments far surpass the capabilities of Apollo-era equipment, offering sensitivity levels that can detect even the most subtle geological events. The Farside Seismic Suite will mark the first time humans have placed seismometers on the hemisphere of the Moon that never faces Earth. This positioning allows scientists to triangulate seismic event sources with much greater precision than previously possible. The instruments are 30 times more sensitive than Apollo equipment, capable of detecting faint tremors from deep within the lunar interior. The Lunar Environment Monitoring Station will establish long-duration seismic monitoring near the South Pole, where Artemis missions plan to build permanent human presence. Unlike Apollo instruments that operated for limited periods, this system will continuously monitor lunar seismic activity for months or years, essential for capturing rare events and establishing long-term patterns. These advanced systems might finally confirm whether the moon experiences slow quakes tied to core readjustment, similar to Earth's slow earthquakes that gradually release energy over extended periods. Such phenomena could explain the mysterious seismic pulses that have captured scientific attention and prompted warnings from researchers like Michio Kaku about the moon's changing internal dynamics. Advanced monitoring technology. Michio Kaku often highlights that humanity exists in a rare cosmic window, a fleeting moment in astronomical time when we can witness and study the moon's internal dynamics before they cease forever. In another billion years, the moon's core may freeze completely solid, making current observations irreplaceable scientific data about planetary death. This perspective transforms lunar exploration from mere curiosity to urgent scientific priority. We're not just studying a neighboring world. We're capturing data during a unique period that will never repeat itself. The moon provides a live demonstration of how small planetary bodies evolve and eventually become geologically inactive. The seismic signals detected from the moon's core might represent one of the final chapters in a 4.5 billion-year story. As the lunar interior continues cooling, these tremors will become increasingly rare until they stop completely. Once the core solidifies entirely, the moon will truly become the dead world scientists incorrectly assumed it already was. Scientists often discuss the importance of being in the right place at the right time. In astronomical terms, humanity exists in an incredibly narrow window. After the moon has cooled enough for us to study its interior, but before it freezes completely and goes silent forever. This unique moment gives us opportunities not just to understand our nearest celestial neighbor, but to develop models applicable to countless worlds throughout the galaxy. The lessons learned from the moon's core could help identify potentially habitable exoplanets and understand how geological evolution affects their ability to support life. The mysterious seismic signals from the moon's core represent far more than geological curiosity. They're windows into planetary evolution happening in real time. Michio Kaku's warnings remind us that we're witnessing the final chapters of the moon's geological story, a rare cosmic opportunity that won't last forever. As humanity prepares to return to the lunar surface, understanding these internal dynamics becomes crucial for mission safety and scientific advancement. The moon continues teaching us about planetary evolution, magnetic field generation, and the delicate relationships that make life possible throughout the universe. After 46 years of exploration, Voyager 1 has finally broken through the ultimate barrier, the heliosphere, and entered true interstellar space. But, the data streaming back from 15 billion miles away is completely rewriting everything scientists thought they knew about the void between stars. This isn't the empty darkness we expected. The space beyond our solar system's protective bubble is alive with invisible forces, mysterious structures, and phenomena that challenge our understanding of the galaxy itself. Today, we're exploring 10 groundbreaking discoveries that prove interstellar space is nothing like we imagined. The magnetic field mystery. The first shock hit scientists when Voyager 1's magnetometer detected something completely unexpected in 2012. Instead of finding chaotic, randomly oriented magnetic fields, the spacecraft discovered that interstellar space has a surprisingly organized magnetic structure. Dr. Leonard Berlanga, from NASA's Goddard Space Flight Center, was among the first to analyze these readings, revealing that the interstellar magnetic field runs nearly perpendicular to our solar system's magnetic field. This sharp 90-degree misalignment suggests we're encountering the edge of a massive galactic magnetic domain. The implications are staggering. These aren't local phenomena but galaxy-wide structures that could influence star formation, cosmic ray propagation, and even the evolution of planetary systems. The magnetic field strength measured at 0.4 nanotesla is actually stronger than predicted, indicating that interstellar space contains more organized energy than our models suggested. This discovery fundamentally changes how we understand magnetic field interactions on galactic scales.
The cosmic ray bombardment.
Crossing the heliopause in August 2012, Voyager 1 immediately encountered a radiation environment that defied all expectations. Dr. Edward Stone, the mission's project scientist since 1977, watched in amazement as cosmic ray levels spiked by 300% almost instantly. These high-energy particles, accelerated by distant supernova and black holes, bombard everything in interstellar space at intensities that would be lethal to unprotected astronauts. The cosmic ray subsystem aboard Voyager detected particles with energies exceeding 100 million electron volts, radiation levels so intense they would fry electronic equipment within months. But here's the most surprising part. The cosmic ray patterns aren't random. Voyager's instruments have measured systematic variations that suggest interstellar space has natural radiation corridors and safe zones. These findings prove our sun's heliosphere acts as a far more effective cosmic ray shield than anyone realized, protecting Earth and our entire solar system from this invisible galactic storm.
The plasma wave discovery.
Silence doesn't exist in interstellar space. Voyager 1's plasma wave subsystem, designed by Dr. Donald Gurnett at the University of Iowa, has been detecting constant low-frequency oscillations since entering the interstellar medium. These aren't random static, they're organized plasma waves that create what scientists now call the interstellar hum. Operating at frequencies between 2 and 3 kHz, these waves indicate that interstellar space is filled with electrically charged particles constantly in motion. Dr. Stella Acker, a Cornell University researcher, recently analyzed 5 years of this data and discovered that these plasma oscillations change frequency as Voyager moves through different regions. The waves intensify near density boundaries and quiet down in more uniform areas, creating an acoustic map of interstellar structure. This discovery proves that interstellar space isn't a void, but an active medium where plasma waves propagate across vast distances, potentially carrying information about distant stellar explosions, magnetic field reconnections, and other galactic events happening light-years away.
The local interstellar cloud.
Voyager 1 isn't just floating through empty space, it's actually swimming through what astronomers call the local interstellar cloud. Dr. Priscilla Frisch from the University of Chicago has spent decades studying this region, and Voyager's direct measurements have confirmed her theoretical models. This interstellar cloud extends roughly 30 light-years in all directions around our solar system, and contains about 0.3 atoms per cubic centimeter, which is incredibly sparse by Earth standards but still significantly denser than the cosmic void beyond. The cloud formed approximately 4 to 5 million years ago when multiple supernova explosions carved out a cavity in the interstellar medium. Voyager's instruments have detected the cloud's temperature at around 6,000 Kelvin, and confirmed it's moving relative to our solar system at 26 kilometers per second. As we drift through this cloud over the next 50,000 years, it'll gradually affect Earth's climate by modulating the cosmic ray flux that reaches our planet, potentially influencing cloud formation and atmospheric chemistry in subtle but measurable ways.
The heliosphere's true shape.
Everything we thought we knew about our solar system's protective bubble was, well, wrong. Voyager 1's journey has revealed that the heliosphere isn't the neat comet-shaped structure you might remember from textbooks. Dr. Merav Ofer from Boston University has been leading research using Voyager data, and her team discovered that our solar system's boundary is far more complex and turbulent than anyone predicted. The heliopause, that's the boundary between the solar wind and interstellar medium, varies dramatically in different directions. While Voyager 1 crossed this boundary at 121 astronomical units from the Sun, Voyager 2 encountered it at 119 AU, but in a completely different region with its own distinct characteristics. NASA's New Horizons spacecraft, still approaching this boundary, is providing even more data points that suggest the heliosphere might have a more irregular, possibly even fragmented structure. This discovery has profound implications for cosmic ray shielding and helps explain why the interstellar medium penetrates more deeply into our solar system than models predicted, creating these complex interaction zones where solar and interstellar forces are constantly battling for dominance.
The density fluctuations.
Interstellar space actually has weather, and Voyager 1 is our very first weather station beyond the solar system. Since 2013, The spacecraft's plasma wave instrument has detected at least 5 distinct density variations in the interstellar medium, each representing a different climate zone in deep space. Dr. Bill Kurth from the University of Iowa analyzed these fluctuations and found that interstellar plasma density can change by factors of 2 to 3 over relatively short distances. The most dramatic shift happened in 2014 when Voyager encountered a density spike that lasted several months, indicating passage through a compressed region possibly created by stellar winds from nearby stars. These variations aren't just random, they actually follow patterns that suggest interstellar space has structure on multiple scales. Some regions are compressed by shock waves from ancient supernovae, while others are rarefied cavities carved out by stellar winds. Voyager's measurements reveal that our local interstellar cloud has internal boundaries and substructures, making interstellar space far more dynamic and organized than the uniform medium astronomers once envisioned.
The galactic coordinates.
Every measurement Voyager 1 takes is helping scientists build humanity's first three-dimensional map of interstellar space. Dr. Nathan Schwadron from the University of New Hampshire leads the team creating these galactic coordinate systems using Voyager's position as a fixed reference point about 15 billion miles from Earth. The spacecraft's current trajectory takes it toward the constellation Ophiuchus, where it will continue for thousands of years unless it's deflected by gravitational encounters. But Voyager isn't just traveling in a straight line, it's mapping magnetic field orientations, plasma densities, and cosmic ray gradients that, vary by galactic location. These measurements reveal that interstellar space has preferred directions and asymmetrical structures aligned with our galaxy's rotation. The magnetic field Voyager measures points toward the galactic center in some regions and away in others, suggesting complex field line geometries shaped by stellar formation and supernova events over millions of years. This galactic GPS system will eventually guide future interstellar missions, helping them navigate the invisible currents and radiation zones that Voyager is now charting for the first time.
The temperature paradox.
Interstellar space is simultaneously scorching hot and freezing cold, and Voyager 1 has measured both extremes. The interstellar medium itself reaches temperatures of 50,000 to 100,000 Kelvin, hot enough to vaporize any known material. Yet, Voyager's instruments register near absolute zero temperatures because the particle density is so low that there's virtually no heat transfer. Dr. Gary Zank from the University of Alabama explains this paradox. Individual plasma particles move at tremendous speeds, which means high temperature, but they're so spread out that the spacecraft actually experiences the cold of deep space. Voyager's cosmic ray subsystem has detected temperature variations in different regions of interstellar space, with some areas reaching 200,000 Kelvin, where shock waves from stellar explosions have compressed and heated the plasma. These temperature measurements reveal the energy budget of interstellar space, showing how supernova explosions, stellar winds, and galactic rotation, pump energy into the interstellar medium. Understanding these thermal processes is crucial for predicting how interstellar gas eventually collapses to form new stars and planetary systems.
The communication miracle.
Keeping Voyager 1 alive and transmitting from interstellar space represents honestly one of NASA's greatest technical achievements. Suzanne Dodd, Voyager project manager at JPL, oversees a mission using 1970s technology to communicate across interstellar distances. The spacecraft transmits with just 23 watts of power, less than a refrigerator light bulb. Yet NASA's Deep Space Network can still detect its whisper-faint signals after they travel for 22 hours at the speed of light. In late 2023, Voyager suffered a critical computer failure when cosmic radiation corrupted its flight data subsystem. Engineers led by Linda Spilker performed digital surgery across 15 billion miles, reprogramming 1970s computer code to bypass damaged memory sectors. The repair took months because every command required a 44-hour round trip for confirmation. By April 2024, they successfully restored communication with all 4 active science instruments. This remarkable resurrection really proves that American engineering from the space race era was built to last, giving us precious additional years of interstellar data from humanity's most distant explorer.
The Golden Record's journey.
Beyond its scientific mission, Voyager 1 carries humanity's greatest time capsule into eternity. The Golden Record, curated by Carl Sagan and Anne Druyan in 1977, contains sounds, music, and images representing Earth's diversity in 55 languages. Dr. Timothy Ferris, who produced the record, selected Bach, Beethoven, Chuck Berry, and traditional music from around the world. NASA engineers designed the record to survive billions of years in space, with instructions engraved in pure gold showing how to play it and how to locate Earth. The record includes greetings from President Jimmy Carter, UN Secretary General Kurt Waldheim, and children from all around the world. As Voyager travels toward the star Gliese 445, it'll make its closest stellar approach in 40,000 years, passing within 1.6 light-years of this red dwarf. Even after Earth's continents drift beyond recognition and human civilization evolves beyond imagination, the Golden Record will preserve our 1970s snapshot of humanity. Carl Sagan called it a bottle cast into the cosmic ocean, and now that bottle has reached the interstellar sea, carrying our message to whatever intelligence might someday find it drifting among the stars. Voyager 1 has shattered, well, just about every assumption about interstellar space, revealing a cosmic environment that's structured, active, and far more complex than we ever imagined. From magnetic field mysteries to plasma weather systems, this 1970s spacecraft continues revolutionizing our understanding of the galaxy itself. Voyager proves we live in a protected cosmic oasis, shielded from the harsh radiation of deep space. So, which discovery amazed you most? Drop your thoughts below. If you loved exploring these interstellar revelations, hit that like button, share with space enthusiasts, and subscribe to Future Facts for more incredible cosmic discoveries.